Welcome to Web Handling. My name is Dave Roysam. I am super excited to continue our new mini-series on machine speed controls. In this week's show, we discuss just a few of the complications of using speed difference control, sometimes known as draw control. These include not knowing what the web's tension is, not being able to automatically compensate for upstream changes or changes in temperature or moisture, confusion on how draw settings are obtained, precisions required for stiff materials, and more. I know your time is precious, so let's get started. Let us be clear about what we will be talking about by first talking about what we are not talking about. We are not referring to the speed of the master or pacer, of which there can only be one. Rather, it is the speed difference between 2 points. We are also not referring to true drawing processes where permanent elongation is the intent. These would include film extrusion dies, film orientation such as biax processes, just after non-woven spinnerets, creping a tissue, and more. What story remains after we remove the prior drive elements? The story that remains is clearly one of complications. These include not knowing what the web's tension is, not being able to automatically compensate for upstream changes or changes in temperature or moisture, confusion on how draw settings are obtained, precision required for stiff materials, and more. The 5,000 students who have taken my award-winning and trademark Web 101 class will recall this slide showing how, on paper at least, it might be possible to convert draw settings to absolute tension with simple one-line equations. However, as my students should also recall, to get absolute tensions anywhere, you must know absolute tensions somewhere. However, without a load cell, dancer, or similar tension sensor, we have absolutely nothing to get started with. The bottom line is that we seldom know tension anywhere on draw-controlled systems, and that should make everyone uncomfortable, especially web handlers. Also, as my students should recall, the pure draw control system has no way to know about and thus compensate for upstream disturbances from any source. Hence, an upset anywhere for any reason will simply pass downstream without any correction. This is easy to understand because the drive, without having information from load cells, dancers, and the like, has no knowledge about upsets that need correcting, and thus are running entirely blind. Thus, in a very real sense, draw control does not really directly control anything about the web. At best, it affects the web in some very complicated and poorly understood way. Just two of the many possible upsets are any intentional or unintentional changes in temperature or moisture. Another major point of confusion is how draw control settings are obtained. They are not obtained by engineers calculating anything, because engineers are nowhere near smart enough to do that. Rather, it is by machine operators who make a draw adjustment based on visual observation of the web's behavior. The way to think about this is that the system is closed loop, but it is the operator's eyes or hands that are the load cell. The repeatability and response of human eyes or hands should make everybody uncomfortable. There are many, many other complications with speed difference or draw control. Too many to cover here. Instead, we will close with just one last item. It is, given typical positions for speed control, how stretchy must the web be in order to hold web tension steady, to say 5%. The short answer is the web must be so stretchy that you can see it stretch by pulling on it with your hand. Those of you who follow my work will see that this is the inverse of the problem statement made in recent shows. There, we showed the speed precisions required to run stiff materials, whereas here we show how flexible materials need to be to obtain tension consistency given typical speed precisions. As we've hopefully demonstrated, speed control is exceedingly complicated for everyone, with perhaps the exception of electrical engineers, who merely need to control motor speed. Also, the variability and uncertainty increases with stiff materials and upstream upsets or midstream upsets. Also, the one way to improve the situation is to use load cells, even if just for monitoring, just about anywhere they can physically be mounted. Still, as we've started this discussion, there are true drawing and other processes where we have no choice but to use speed difference control. That does not make life any less complicated, only that we don't have a choice but to best live with those complications. I hope you've enjoyed this discussion of speed differential or draw control. Stay tuned for next week's show, where we will discuss speed difference control used for certain dual drive winders as well as dual drive laminating points. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.